But guess what? Y'all are gonna have to factor again.
So it's a lot harder.
Y'all are gonna get good at factoring. I promise you are.
Yeah, it's a lot harder.
Eventually, I'm gonna make it happen. All right. So let's look at example number 3 here. We are going to still solving for x, still having to check for extraneous solutions. We did run into one of those yesterday. When we plugged it back in, it made our denominator 0. We cannot divide by 0, so even though we got it as an answer, we had to throw it out. So let's look at this one right here. We've got to find the LCD, but guess what? It doesn't have 3 separate pieces, okay? Because what can we do with that last denominator there? We can factor it out. Yay, y'all are finally starting to recognize that. All right, that is x times x plus 1. So that is our LCD, x times x plus 1. All right, x times x plus 1. So we go through, just like with complex fractions, we multiply each thing with x times x plus 1. And I'm just going to go ahead and write it all out, and then I'll go back and cancel. So in the first one, x plus 1 cancels, so we've got x times x plus 3 equals, in the second one, x cancels, so we've got x minus 3 times x plus 1. And in the third one, the entire denominator and numerator cancel, but we still have to put the plus 1, okay? Because when things cancel, it's not 0. When things cancel, it reduces to 1. So now we need to multiply everything out and try and combine like terms if possible. So we've got x squared plus 3x on the left side. When we FOIL that out, we get x squared minus 2x minus 3. Now, it looks like we've got a quadratic equation, right? What do quadratic equations have to be equal to before we can solve? 0. Okay, so if we start that process, I'm going to move it to the right side. Well, guess what? We luck out. The x squared cancels, so it's not actually a quadratic equation. It's only a linear equation. So the x squares cancel, so we've got 3x is equal to negative 2x minus 2. And then it's just a matter of solving. Add 2x, so we've got 5x equals negative 2. Divide by 5, bless you. We get negative 2 over 5 for our answer. And it wouldn't hurt. We need to check it. It doesn't make our denominator 0. What would make our denominators 0? 2 options. Would 1 make the denominator 0? Somebody said negative 1. What else would make the denominator 0? Look at that middle denominator right there. 0, right? Negative 1 and 0. If we got those as answers, we would automatically throw them out. But we didn't. We got negative 2/5. So let's just double check and make sure that everything's okay. Because sometimes when we get fractions, I mean, it's not unusual to get a fraction for an answer, okay? I don't want you to shy away from fractions as answers, but a lot of times these questions are designed so that they get whole number answers, so I would be a little wary if I got a fraction. Now notice, you gotta put parentheses in there for 2 reasons, because it's a fraction and because it's negative. You got to make sure you get plenty of your parentheses around there or it will not work out correctly, but it did. Left side equals right side. So negative 2/5 is our answer. Okay. Alrighty. It's not that bad. It's not fair. Can you whine a little bit more? Okay. It's really not that bad because there is a lot of overlap in these denominators. There's a lot of overlap in these denominators. So let's just go ahead and So while y'all are writing, I'm going to start thinking. Okay, and I'm going to start factoring. The first denominator, we need to take out an x. The second denominator, we need to take out an x, and we can factor it. Just to save myself some space, I'm going to do those two things at one time. Okay, not to freak you out. But I took out the x, and then I factored x squared plus 10x plus 24. Oh, and guess what? That just happens to be the third denominator as well. So x plus 6 times x plus 4. Well, look at that. So it's really not that bad. We've got x, x plus 6, and x plus 4. Okay, so go through, and we've got x, x plus 6, x plus 4. X, x plus 6, x plus 4. X, x plus 6, x plus 4. All right. So first one, x and x plus 6, gone. 3x minus 9, x plus 4, all we got left. Excuse me. The second one, everything but what was originally in the numerator cancels. So we really don't need parentheses around it because there's nothing to multiply it by. In the second one, the x plus 6 and the x plus 4 cancel, so we've just got 1 times x, which is, of course, x. So really, something that started as a really big problem has already become a fairly small problem. Okay? So what do we need to do on the left side? FOIL and combine like terms, right? So 3x squared plus 12x minus 9x, so plus 3x. And negative 9 times 4 is negative 36. And on the right side, combine those x's, 2x minus 6. Okay, this one is definitely a quadratic, and it's going to stay a quadratic because we only have x squared on one side. So that means everything needs to be on the same side as that x squared. So in one step, I'm going to subtract the 2x and add the 6. 3x squared plus x minus 30 equals 0. Now let me let you in on a little secret on these problems. Any quadratic that you run into will be factorable. Okay, any quadratic that you run into on these will be factorable. So if you get a quadratic that's not factorable, you need to look back a couple of steps and see if you messed something up, okay? Because that you're not going to have to use the quadratic formula. You're not going to have to graph to find these answers. They are all factorable. So we've got 3x and x. Okay, what do y'all think? Factors of 30. What do you think we should use? Lovely. Negative 3 and positive 10. But the 10 needs to come first. The 10 needs to be with the 3. Okay? Because the outside's going to give us negative 9x. The inside's going to give us positive 10x. That's what's going to give us that positive 1x in the middle. All right, so let's solve. 3x plus 10 equals 0. X minus 3 equals 0. So that one's easy. X equals 3. The other one is 3x equals negative 10, so x equals negative 10 over 3. Oh, that's a little lengthy, isn't it? So let's just check and see if 3 or negative 10/3 is a problem. Are either of those a problem? Like, would they make the denominator 0? Yes? Negative 10/3 would make the denominator 0. Plug it in. Plug it into the denominator. 3 times 3 plus 6. Is that going to be 0? No. Negative 10/3 times negative 10/3 plus 6. Is that going to be 0? I don't know exactly what it is, but it ain't 0. Okay? So neither of those are problems. So really, that's the biggest thing you're looking for with an extraneous solution is, does it make the denominator 0? Okay, pretty much if you get it as an answer and it doesn't make the denominator equal 0, chances are it's going to check out. Now you can of course plug it in and check, but obviously this one would take you a little bit of time to plug it in. So that's why I'm kind of shying away from it. But anyways, the big thing is, does it make the denominator equal 0? If the answer is no, you're good. Roll with it. Okay? All right.